And next we have Josh Reynolds.
Hey everyone, just going to share my screen here. Okay, everybody can see that okay? Cool. All right, so I'm here to talk to you about reverse engineering with a model context protocol server that I created for a reverse engineering platform called Binary Ninja. So I'm the founder of a reverse engineering and malware analysis startup based in Toronto, Canada called InvokeRE. So I do a whole ton of reverse engineering and malware analysis. So I was looking to create something to speed up that workflow. I'm sure a number of you have heard of this thing called MCP, and effectively it's just a protocol that was developed by Anthropic in order to provide tools to various large language models and tool-based large language models that can call various tools based on that protocol. So this is how this MCP server works. Basically, we have an agent interface or a large language model interface that interacts with the MCP server locally. This is just done over local sockets in this version of my MCP server that communicates with an HTTP REST API, which is listening on my Binary Ninja instance, so my reverse engineering platform instance. And then basically these protocol tools are used to retrieve and modify the Binary Ninja database as it reverse engineers the given binary. So for today, I just have a really basic example of a malware loader called Coiloader. This is used to load a steal or malware variant that is used to steal information from computers. And this is what the Binary Ninja instance looks like. This is a pretty basic malware example, but this is great for a demo. So here in this instance, I'm using Cursor for my agent. Cursor has the native support for MCP servers, so it's a really good opportunity to use this. And it has the ability to understand code very well out of the box with their little agent that they have. Not little, it's probably pretty grandiose in terms of complexity, but it's really good at interpreting code. So we're going to be pulling a bunch of different code and interpreting it here. So my prompt is, you are an expert reverse engineer and use Binary Ninja to analyze binaries, analyze the provided binary to find indicators of compromise that can be used to detect any malicious activity. So I'm just going to hit enter here. And basically what's going to happen is it's going to use all the tools that I've defined with my MCP protocol in order to analyze the provided binary. So as you can see, this is quite fast. Basically, it's looked through the binary itself and it's come up with a few examples here. So again, this is non-deterministic because this is a large language model and it has things like temperature. So I'm curious to see what it comes up with here. So it looks like it has come up with some pretty useful indicators out of the binary in that, what was that, like a 2-second process in which it is summarizing for me now. So here, I'm just going to go through a few of these, but it's even provided things like detection recommendations and things like that, which is pretty cool. So it has a outbound network connection to this URL. It has things like the mutexes that are created on the system and defines how those are created. This is using the system GUID, so it's not very good for detection in this case, but that's okay. It calls a PowerShell command and things like that. And it's even prompted me here at the end, would you like more detailed breakdown or a YARA slash Suricata rule for these IOCs? And I can just even say, yes, please make these rules for me. And let's see how this does. So for any of you who have done some serious detection engineering, you'll know that obviously this is a pretty false positive prone process, even when a human is writing them. So when you're leaving this up to large language models, it's probably not the greatest, but let's take a look at what it generates here. So it was able to determine that this was Coiloader probably based on the file name that it was able to acquire using the MCP server. But let's take a look at some of the rules that it just created for us. So here, again, this is a string-based rule, which isn't super great when you're doing malware research because they can, just change this URL and then this breaks. But then it has like the parameter that's passed to the PowerShell script. It has the fact that PowerShell is called, and it might be listening to this call right now because it actually created a mutex GUID for the the YARA rule here. I don't actually know if this would work because this is created at runtime, but still pretty interesting. And what's for any of you who actually write YARA rules, this is good practice where you can say like any of these things and then plus a more granular piece of the rule. So this mutex generation, GUID generation with any of these. So it created a Suricata rule for us as well. So for any of you who do network-based detections, this is quite cool. So for in this instance, basically it's just looking for any HTTP traffic to a given IP address. And then it is also looking for the HTTP URI with that unique value. So I think this would be a pretty good rule in production. It wouldn't false positive prone, but not very useful because it's just using those hard coded indicators. And then we're seeing here that it's also looking for the content of PowerShell and the HTTP URI. This is not a good rule because this really makes no sense. And then it's also produced a Sigma rule here, which is pretty cool. So it's basically just looking for the image ends with PowerShell.exe and then the command line containing that command. So this would also probably not only match on this particular malware variant. So again, not super great, but these are all really good starting points. And we can even say things like, hey, can you continue to analyze this binary, make changes to the binary ninja database to reflect your findings and summarize what you find. So in this instance, I was just asking it to retrieve information, but now I'm actually asking it to modify the database. So we'll see kind of what it does. So it's adding a bunch of comments to the given functions. So like performs cryptographic operations. And these are all things that you would do for those of you who do not do reverse engineering. You would do all of these things throughout your reverse engineering process. So just me saying, documenting your findings, it's adding a whole bunch of comments to all these different functions and then effectively documenting those functions within the binary ninja database. So that's pretty cool. And then it's summarizing the findings here. So the anti-analysis techniques used, the persistence and environment setup, not startup, the cryptographic and obfuscation operations that are used, some payload unpacking techniques, the process manipulation and injections. Because this is a loader, this is actually doing process manipulation and injection. The C2 communications that I just talked about in those rules, the file operations. So the fact that it's creating something in temp is really good to make note of. Timing, anti-analysis, and stuff like that. So, and it's just summarized as changes here. So then if we go back to the binary ninja database, then we can see those comments have been applied to the database here. And one thing that's notable about this malware variant is it is created to not execute within the Commonwealth of Independent State Countries or the former Commonwealth of Independent State Countries, which is common for malware written in Eastern Europe. And then, so that's what that language check is for there. So it found that. And then we can also see that it is creating a GUID here. So this is all pretty basic stuff that you could find just doing some reverse engineering yourself. But again, it finds it really fast and then does a whole bunch of stuff for you. So pretty cool.
That's
I don't
awesome.
know.
Josh, I was gonna say we have a few questions from the chat if you got a sec on it.
Yeah, for
One
sure.
one of them's mine, which goes back to other presentations like this we've seen, which is like, is it possible to give it like a snort or YARA style guide as part of every prompt? And so then when it spits it out, it's like, hey, I'm not looking at PDP paths or raw IP or some random thing that's in every single packet.
Yeah, I think there's definitely a lot of work in that area that could be done. So with like what JB did earlier, which is like defining what you want in terms of your rule outputs and things like that. This is literally me just using the cursor agent. I didn't provide it with any system prompts or anything like that. So that's definitely an area for research there. Um, let's see, more talk about Obsidian. Ask it to
But one of
target
the
obfuscation techniques. Go ahead.
well, one of the other one Adam asked was, can I use this without giving you access to the binary I'm looking at?
Yeah, so this is actually basically you're just giving this information to the cursor large language models, which isn't great, but there's definitely ways to bring this offline. I'm actually looking at doing that on I have like a M2 Mac. So yeah, you don't give me any of this actually. This isn't like a service. This is just an open source project that you all can use with Cursor or any other client that understands MCP today. So obviously you would need a binary ninja license as well. So it's a commercial product, but I'm a huge fan of Binary Ninja because their API is really good and it's really well supported. So
Awesome.
I don't know if I can find any other questions. I'm gonna scroll back here. But yeah, I think I'm over time. I don't know if we restarted the timer, but it says
We had like
minus...
several extreme votes for you to get
cool.
more.
Okay.
So
sorry.
That's okay.
Thanks, everybody.
So yeah, absolutely. Thank you.
Cool. Yeah.
Next.